Hey everybody, today we're going to be talking about metallic bonding. We're going to go through this worksheet. It's a pretty short one, pretty quick. What types of atoms combine to form a metallic bond? Well, that should be clear. It's metals. All right, and typically it'll be two or more metals that we put together. Sometimes you'll just have one metal, but you could have two metals that are put together, and sometimes we'll throw in something that's not a metal like carbon. Right, but usually it's multiple metals forming together. Right. So give me two examples of a metallic compound. Well, part of it is the fact that it's a compound, so I can't just say something like iron or zinc or nickel or gold or silver, all right, because those are not compounds. All right, so you can't do any of those. But what you can do is you can do stuff like, let's say I put iron and I put chromium in it, and that plus a couple of other little things are going to make stainless steel. Right? We talked in the podcast about making things like brass and making things like, for example, 14 karat gold. All right, which is not pure gold because pure gold is too soft to be used for jewelry. So we take gold and we mix it with silver, and we mix it with some other stuff to make 14 karat gold. Right, so those are just some examples. All right, in a metallic bond, the valence electrons form A, and the answer here is sea of electrons. In other words, the electrons really don't belong to one particular atom. Okay, they kind of float around between a bunch of them. Okay, and so that allows metals to have certain properties because the electrons are more free to move. So, what's an alloy? An alloy is something where you mix multiple metals together. Again, 14 karat gold would be an alloy. Brass would be an alloy because brass is made up of multiple metals. We mentioned lots of metals in the podcast that were alloys. Right? So an alloy is a mixture of two or more metals. Okay, so for example, we talked about one that was mainly tin, but there were other things in it as well. So those are, an alloy is a mixture, a solution, all right, a solid solution of multiple metals put together. In other words, you can't see one or the other, you now just see a mixture of them. Okay. What is the model that accounts for the most important characteristics of metals? Well, again, that's the sea of electrons. All right. So, list 4 properties of metals that can be explained by the model described in the previous problem. So we think of the sea of electrons, and this allows metals to conduct electricity. And the reason for this is the electrons can move quickly and freely between the atoms, and what is electricity? But it's just the flow of electrons. So that's why metals work so well as conductors. They also conduct heat really well, and that's because the atoms can move around, and they can the electrons can move around. All of that allows more movement, more freedom of movement, and the more something moves, the hotter it is. Okay, we talk about malleability. All right, this is the ability to pound a metal into a sheet. And again, the electrons, everything has to be able to move for that to happen. You can't pound salt into a sheet. It doesn't matter. It gets pulverized. It turns into powder. Right? Well, that's not true with a metal. You can actually bend it, shape it, reshape it, and that's all because the electrons can move. Right? And the last thing we're going to talk about is ductility. And ductility is all about pulling something into a wire, stretching it, making it form into a wire. And again, metals do this because the atoms can all move. So the atoms can readjust, if you will. All right, and as they readjust, as they readjust, as they move around, the electrons move with them, and everything just kind of resets into a new shape. Okay, so that's why metals are malleable and ductile. All right. And why are they good conductors of electricity? Well, again, the electrons can move. The electrons are free to move whenever they want because they're not attached to one particular atom. So that makes it an excellent conductor of electricity. So that's it, folks. If you have questions, see me in class, and I'm happy to answer any questions that you have. Okay? See you then. Bye-bye.